Okay, this next section is not about whether a series converges or diverges. Basically, these are sort of labels that you assign to a particular series. So every series can be labeled as either absolutely convergent or it can be called conditionally convergent. If not either of those, then we just say it's divergent. The definition of a series that's absolutely convergent is if the absolute value of the series converges and the series itself without the absolute value also converges. We say it's absolutely convergent. Something is called conditionally convergent if the series converges, but if you look at the absolute value of the series, it diverges. So basically, we're just going to put a label on these series as either absolutely convergent, conditionally convergent, or possibly it may be divergent. So for instance, look at this first series right here. Okay, so you have to figure out, I always start with the absolute value piece. So the absolute value piece is this series right here. Okay, so when I look at just the absolute value, I can say for sure that this is a P series that diverges. Now when I look at the whole series, I notice it is an alternating series. So I'm going to use the alternating series test on the whole series. And is it true that the limit is equal to 0? Yes. And is it true that the n plus first term is less than the nth term? Yes. So I would say it converges by AST. So if the absolute value diverges, but the series converges, we call it conditionally convergent. That's the label that we put on this series. So let's look at these three problems down here. So I always start with just the absolute value piece. Here's the absolute value piece. I can say this is a P series that diverges. Okay. Next, let's go ahead and look at the entire series with the -1. So it is an alternating series. So I'm going to check my two conditions for an alternating series. Is it true that the limit of the general term is equal to 0? Yes. Is it also true that the n plus first term is less than or it could be equal to the nth term? Yes. So I can say the series itself converges. So if the absolute value diverges but the series converges, we call it conditionally convergent, and I'm going to call it CC for short. Okay, try the next one. Okay, if I look at just the absolute value piece, this is my series. Okay, quickest way to do this is recognize it's a geometric. R is 1/3, so the absolute value series converges. Now let's look at the entire series with the -1. Okay, notice it's also a geometric. You can use the alternating series test if you want, but I don't need to. Your R is -1/3, which also converges. So if the absolute value converges and the entire series with the -1 converges, we call it absolutely convergent, which I'm going to use AC for short. Okay, last one. If you want to try this on your own, pause it and then come back. Okay, let's check the absolute value piece first. Okay, I don't recognize this as something right away that I can do. Okay, I can go ahead and do a couple different things. You can do some type of comparison if you want. I'm going to go ahead and compare it to 1 over n plus 1. And I know if I use the integral test, if you actually integrate this, 1 over x plus 1 dx, this is the natural log of x plus 1. Forgot my limit sign. Okay, if you take this limit is infinity, so I know that this diverges because of the integral test. Okay, now go back to your original series and let's compare it. So I know that this series, because you are taking the log of a function, which slows down the growth, so this will always be bigger than this because the log is on the bottom. So because this diverges, anything bigger will also diverge by your direct comparison test. So lots of work just for this absolute value piece. Okay, now let's look at the entire series with the -1. So it's an alternating series, so I'm going to use the alternating series test. And is it true that the limit of the general term is 0? Yes, it is. Is it true that the n plus first term is less than the n plus nth term? Yes, so I can say it converges by AST. So the absolute value piece diverged. The entire series with the -1 converged. So this is going to be labeled as conditionally convergent.